Hello everyone, thanks for joining our talk today called Infra Security Automation in CI/CD Impossible is Nothing. And that's because we will share with you our challenges, our struggles, mostly our struggles, but also our success. I'm Davide Cioccia, and together with me today there will be my colleague Spiros Manglis. I personally come from Italy, but I've been living in the Netherlands for almost 5 years now. And I hold the security engineer position in the AppSec team of ING Netherlands. Personally, I enjoy speaking at conferences about different topics, giving cybersecurity trainings together with some friends at the DevDev EU. Today we want to share with you the challenges we constantly face when it comes to making and keeping a complex environment like the ING one secure, especially how we moved from manual infrastructure security testing to automated testing and why we needed to do that. This talk will guide you through the process we went through to reach an advanced level of automation using a combination of well-known technologies and industry standards, and we'll also give you an insight of the framework we created. At the end, we'll also present some of the next steps we have already on our roadmap, not yet implemented, but will come soon. And of course, we really hope to have a cool Q&A session at the end. When it comes to creating an application, delivering a service, or putting in production a new idea, testing is a fundamental part of that. The program or component is developed on a development system, like in this case, laptop of the developer. And once the developer is confident enough that the product is ready, the product is copied to a test environment to verify if it works, whether it works as expected or not. And this test environment is supposedly standardized and in close alignment with the target environment, and is mainly used for functional testing. If the tests are successful, then the product is copied to an acceptance environment. That should be the exact copy of the production environment. This environment will be used to conduct integration tests, security tests, and compliance tests. If all of the tests succeeded in acceptance, then the product is deployed to a production environment, making it available to all users of the system. So, as we can see from the slide, this is a really simple DTAP environment that we can use from one service. But now, what happens when your company has millions of users? Your DTAP environment grows exponentially in complexity. It grows in interactions with other systems like load balancers, enterprise service bus, databases, microservices, and more. You can imagine that checking that all of these systems are secure enough and nothing vulnerable is shipped to production will require us years, right, if we do it manually. But also, if we could do it in few days, the environment will be already changed and the previous tests will be invalidated due to the high amount of the releases. Just think that our DevOps teams release multiple times a week and sometimes multiple times a day, right? But to better understand what we are targeting here and introduce some terminology that we are gonna use later in the presentation, we can simplify what's on each server using the stack that you see in the slide. We can right away identify two different blocks, the application layer and the infra layer. The application layer is made of the application running on the machine, and of course the libraries that are used by the application. This can be proprietary libraries, open source libraries, and the third layer will be represented by the system calls made to the underlying operating system. The infra layer is then made of the OS, of course, the binaries that can live in the machine, for example, binaries for monitoring, accessing the machine, and so on, services, ports, files, and more. And like everything we could identify in a physical server or a VM or a container. So now that we know what's our target, what we want to understand is how to assess the security of this stack in a CI/CD environment. If we think about every time a developer commits code, we must provide a feedback as soon as possible. Thus, we can embed like SaaS tools directly in their IDE and use a centralized incremental SaaS tool to assess the deltas. When we look at the stack, we are definitely targeting the first layer. So the application or the API using, for example, SaaS tools. Why am I not including the second layer or completely the second layer? That's because the SaaS tools must be complemented by other tools, such as SCA scanning tools, so software composition analysis scanners that will allow us to make sure that no vulnerable open source library are shipped to production. So the combination of both will make us safe if we consider the top two layers. Okay, so we can say that in the build phase we got the first two layers kind of covered. Okay, the test phase in the CI/CD pipeline is one of the latest phases, and it's where tools like Dust and Yast can be embedded to automate the security assessment of the three layers we identified in the stack. So application, so our code, libraries that are used in our code, and of course the system calls. In a CI environment, code is not shipped to production directly, but a review phase is needed. This can be a manual review, and this is where we actually kind of stuck, because also small deltas must be checked manually. Many times developers just ship to production very small code that sometimes there is no reason for checking it, right? But if we could rely on the tooling we have in place for the first three layers, so the application, the libraries, and the system calls, to overcome the manual pen test, we definitely do not have much that could help in assessing just what changed in the underlying layer, the infrastructure. So using the tools in a CI/CD pipeline like SAS, Dust, Yast, SCA, scanning, or other tools to assess the application, we will definitely cover the first three layers. But the problem comes when infrastructure is in the picture. And what we did so far is just taking a machine where the applications are running and doing a manual pen test, manual infrastructure pen test on it. This introduces a big overhead for testers, for pen testers, and especially also DevOps that want to ship their code in production as soon as possible. They have a very huge block at the end of their pipeline, that is the manual pen test performed by a pen tester. So this overhead brings us to our challenge, actually. And this is how we from the security team felt when someone said, okay, come on, you can actually do it manually. Well, no, we can't. And I want to introduce here our challenge, because maybe it's not clear. So the problem we're facing here is that manual infrastructure security testing is a big overhead for DevOps. It's a big overhead because there are like 2 weeks time where the application is stuck in acceptance in order to be checked. And you know, the number of people in the security team is like 100 times less than the number of people in a development team. Also, the machines, the virtual machines, the images, the Docker images are only assessed on provisioning. So that means that the security of these images of the infrastructure is only checked when the machine is actually provisioned to the team, to the DevOps teams, because in Agile we're working, the DevOps teams are actually responsible for the infrastructure as well. So the infrastructure, the security of the infrastructure is not checked incrementally. Okay, so the changes that are made to the infrastructure, also small changes, are not checked, because complete assessment must be performed. And you can say like, okay, but why don't you use vulnerability assessment tools? And I can say that vulnerability assessment tools are used in these environments mainly for compliance testing, mainly like once a month scanning, because vulnerability tools will not understand the changes and will scan the whole machine every time, over and over. And also, I mean, having like 2000 applications more or less, that means, if we remember the DTAP environment that I've shown before in the slides, that means that we have 20,000 machines at least, and that will bring us to the death of our pen testers. Yeah. So the question is, and the question that brought us to this project is, how can we check the security of the deltas on infra level every time a DevOps commits code and ships it to acceptance for testing? So how can we make the infra security testing a kind of an integration test as part of the CI/CD pipeline? Well, I will pass the mic to my colleague Spiros that will explain you everything about the technical details and the framework that we use to make this happen.